So we practiced factoring yesterday, and we practiced on Excel, and I think that went really well. We do have a test coming up Friday, so I want to start kind of reviewing today. But I wanted to touch base some more on those distributive property that had extra stuff added on. And I thought I need to talk some more about, like, maybe if you have more than one set of parentheses. So let's get started. It won't be a long review because you do have an activity today about a robot named Cyber that you'll need time to do, but I do want to go over those double parentheses problems before you get started on that because there are a couple on there and I want to make sure you know how to do it. So let's say we have a -6 times 2x plus 3y, and then maybe a minus and another set of parentheses, 5x minus 8y plus 5. Okay, so let me get this a little closer so you can see it better. Okay, well, it's not going to let me zoom in, I guess. It's not working. Okay, so hopefully you can see it well enough. Okay, so here you have two different sets of parentheses, and this -6 is directly attached to this set of parentheses. And this is actually a -1. So if you see a minus in between, it is actually a -1. If you don't see anything there, you know there's an imaginary 1 there. So this is directly attached to this set, and this -1 is directly attached to this set. And then this plus 5 is off to itself, so it does not get distributed. So this would be -6 times 2x and -6 times 3y. And then that would be -6 times 2x is -12x, and -6 times 3y is -18y. Then I would need to distribute this. So this is really a -1. So this would be -1 times 5x and -1 times -8y. And then we would just bring this plus 5 down. So -1 times 5x would be -5x. -1 times -8y would be +8y. And then bring down your plus 5. So now you have an expanded form of your original expression. We distributed both sets of parentheses, and now you have this expanded form here. So now we still have to find the like terms and simplify as much as we can. So I have -12x and -5x. Their signs are the same, so I'm going to add them, and I'm going to get -17x. I still have some like terms. I have -18y and +8y. My signs are different, so I'm going to subtract and keep the sign of the largest absolute value. So 18 minus 8 would be -10y. And then I would just bring down this +5. So this is my most simplified version of this expression. So this expression is equal or equivalent to this expression. Let's try another one. This time, let's do 3 times 4f plus 6g minus 2 plus 6 times 2f minus g, and then plus 10 minus 2g. So this is a fairly long expression. Remember, you only distribute the 3 into the parentheses that it is directly attached to. And this 6 is also directly attached to this parenthesis, so you will only distribute it to this group. And then these are not attached at all, so they will just come straight down. So this would be 3 times 4F, 3 times 6G, and 3 times negative 2. And then we would move over here, 6 times 2F, and 6 times negative G. And we know that that negative G is actually a negative 1G. And then we would bring down the rest, plus 10 minus 2G. So now let's distribute. 3 times 4F would be 12F. 3 times 6G would be positive 18G. 3 times negative 2 would be negative 6. 6 times 2F would be positive 12F. And 6 times negative G would be negative 6G. And then, of course, bring down plus 10 minus 2G. Now we have expanded this expression, so now we can find our like terms. We have a positive 12F and another positive 12F, which would be, their signs are the same, so we'll add and we'll get 24F. Now we'll look for G's. We have a positive 18G, we have a negative 6G, and we have a negative 2G. So I'm going to look at my signs of the first two. They are different, so I'm going to subtract and I'm going to get 12G, and it will be positive 12G. And then I'm going to say, I'm going to do it down here just to illustrate for you. Positive 12G minus 2G. Signs are different, so I'm going to subtract, and I'm going to get positive 10G. Now I need to see, do I have any other like terms? And I do. I have negative 6 and positive 10. My signs are different, so I'm going to subtract and keep the sign of the largest absolute value, which is positive. So I'm going to put positive, and 10 minus 6 is 4. So this is equivalent to this long expression up here. We expanded it, and then we got it down to this simplified version here. Let's do another one. So let's have negative times 3h plus 12g minus 6k minus negative 2 plus 6g minus 10k, and then a minus 13. So that looks like a pretty long expression. Let's expand it or distribute. We know that this is a negative 1. So it would be negative 1 times 3h, negative 1 times 12g, and negative 1 times negative 6k. Now, this is also a negative 1 attached to this parenthesis. So this would be negative 1 times negative 2, negative 1 times 6g, and negative 1 times negative 10k. And then, of course, just bring down this negative 13. Now, let's go ahead and multiply that through. Negative 1 times 3h is negative 3h. Negative 1 times positive 12g is negative 12g. Negative 1 times negative 6k is positive 6k. And negative 1 times negative 2 is positive 2. Negative 1 times positive 6g is negative 6g. Negative 1 times negative 10k is positive 10k. And bring your minus 13 down. Now we can simplify. Do we have any more h's? No, we don't. So we're going to bring it down. Negative 3h. Do we have any g's? We do. We have negative 12g and negative 6g. So negative and negative, their signs are the same. So we're going to add and keep the sign of the largest absolute value, which would be negative 18g. Now we're going to check to see if we have k's, and we do. We have a positive 6k and a positive 10k. My signs are the same, so I'm going to add, and I'm going to get positive 16k. And now I'm going to check, do I have any other constant numbers? Remember, a constant number has no variable. So I do. I have a positive 2 and a negative 13. My signs are different, so I'm going to subtract and keep the sign of the largest absolute value, which would be negative 11. Now, that is my most simplified version of this. So negative 3h minus 18g plus 16k minus 11 is equivalent or equal to this. Let's do one more, and then I'll let you get started on your Zyber the robot activity. So let's say we have negative 10 times 4a plus 6b minus 12 plus 8 times 4a plus 5g minus 4. And we're not always going to have extra numbers outside of the parentheses, so we're just not going to have that this time. So this negative 10 is directly attached to this set of parentheses. So this would be negative 10 times 4a, negative 10 times 6b, and negative 10 times negative 12. Now, this 8 is directly attached to this set of parentheses. So this would be 8 times 4a, 8 times 5g, and 8 times negative 4. So now we've expanded it and we can simplify more. So negative 10 times 4a is negative 40a. Negative 10 times 6b is negative 60b. Negative 10 times negative 12 is positive 120. 8 times 4a is positive 28a. Not 28, I'm sorry, 32a. 8 times 5g is positive 40g. And 8 times negative 4 is negative 32. Now we need to check for like terms. I don't see, I do have two a's. I have a negative 4a and a positive 32a. My signs are different, so I'm going to subtract, and I'm going to keep the negative sign, which would be negative 8a. Check for b's. I don't have any more b's, so I'm going to bring that down, negative 60b. I'm going to check for constants, which is just a regular number. I have 2. They are different, so I'm going to subtract. And 120 minus 32 is positive 88. And then I have a 40g left, so I'm just going to bring it down, plus 40g. All right, so I don't have any more like terms. So this expression is equivalent to this expression. Okay, that's enough of this for today. I just wanted to do a short little lesson, a mini lesson on making sure you know how to do it. When there's two or more sets, you can have unlimited amount of parentheses. It's just according to how long you want your problem to be. But you do see two sets pretty often, especially when you get into algebra. So you will do your Google slide activity today on Zyber the robot, and I hope you enjoy it, and I hope you have a great day. Bye bye.